Okay, in this video, I'm going to try to take the entire version of limits from pre-calculus and put it into a quick little video, just the high notes. Of course, there's going to be little ins and outs that you'll want to look through notes and extra homework problems for, but this is the main idea. So, first of all, what is a limit? Well, whenever you see this notation, I really want your brain just to think y value. I mean, this is fancy notation for asking what is the y value? What is the y value when x approaches, in this case, I put a c down there, but that could be any number. So pretty much it's the same thing you've done since, 8th grade with if you know your x, finding your y, and you're going to do the same approaches to doing this. So you can use an equation, you can use a graph, or sometimes you can look at the table of values and see what's happening to that y value. So let me give you an example just to start us off kind of easy here. Let's say that I'm asking for the limit as x approaches 1, and I give you a function like, 2x squared minus x plus 3. Okay, so when you see this, remember, I want your brain to think, what is the y value when x is approaching 1? Well, if I've given you this equation and I want to know what the y value is, hopefully you would think, well, let me just plug it in and see. Because if you're given an x and you want the y, that should be your first step, okay? And when you plug this in, 2 minus 1 plus 3, okay, so I'm getting 4. If you get a real number answer, guys, I mean, like, that is your answer. That is the limit, okay? So I always try plugging in first. Now, if you try to plug it in, the limit as x approaches, let's do the same thing. The limit as x approaches 1, but now let's make it a little more interesting, like maybe this, okay? So if I gave you this function and we tried to plug in the 1, what's going to happen here is we're going to get 5 over 0. Now, anytime you get a number over 0, this actually means that there is a vertical asymptote. And if there's a vertical asymptote happening at 1 on the graph, then the limit does not exist, okay? Because the graph can't approach a specific y value because there's a vertical asymptote there. So anytime it's a number over 0, okay, then you can pretty much assume the limit does not exist. And if you wanted to verify that, some teachers are going to ask you to look at a table of values. So if they say to look at a graph or look at a table, so like here's the equation approach. If you need the graphical approach, then you would type this in on your calculator and take a look at it. And what you would see is something sort of like this. And so if you're looking at the graph when x equals 1, you could see that on this side it's heading down, on this side it's heading up. I mean, it's not heading towards any y value, and that's why it doesn't exist. If they wanted you to do a table of values, what you could do is go to your table function of your calculator and plug in values close to 1, like maybe 0.99, 0.999, and then on the other side of 1 we'd have 1.011, 1, and 1.01. So you could plug in values all around, and what you would be looking for is, are these similar? Okay, so as you get, because this is going to say error, right? Because you can't plug in a 1 because you'll get a 0 on the bottom. But if you plug in stuff really close to 1, are they close together or are they the same? Because if they are, then you would know, oh, the limit does exist and it's right here. But in this problem, I don't know what these values will be, but this one's going to be like some really small or negative number, and this one's probably going to be a positive number, and they would be far apart, so you would say, oh, okay, the limit does not exist. So let's do one where the limit does exist, but at first you might think that it doesn't, okay? So here's another example of where maybe you try to plug it in. Let's do the limit as x approaches 2, and we'll do like 3x squared minus 12 over x minus 2. Okay, so here's an equation where at first, if you try plugging in the 2, because we're looking for a y value here. Always try plugging in first, okay? You're going to get 0 over 0. Now, 0 over 0 is different than the last one, okay? The last one we had a different number, like 5 over 0, and the limit is not going to exist. If you have 0 over 0, it's called undeterminable, which means we don't know what's happening. We don't know what the limit is. And 9 times out of 10, there's going to be some creative way to figure out how to reduce this problem. So sometimes that is factoring. Sometimes you have to take a conjugate. This usually happens when you see a radical. Sometimes you just have to do like fraction math, like common denominator math. So if you see like ugly, complicated fractions, you would do that. But in this case, I can tell this is going to factor. So what I'm going to do is I'm not going to write does not exist. I'm going to recopy the problem and start factoring. So if I take a 3 out first, I'm going to get x squared minus 4. And that actually factors into that. The denominator doesn't factor, but look what happens, guys. Once we factor, we're able to cancel. And so what this tells us, if you remember from earlier in the year, is that there's a hole at 2, but that's okay. If the hole is there, you can actually still have a limit because it's what your y value is trying to get to. So what you could do is now just take that 2 and plug it into what's left, and 12 is the limit. So what this most likely means is this. Here's the equation approach to this problem. If we wanted the graphical approach to this problem, we would graph all of this, okay, on the calculator, and what you're going to see is something sort of like this. Okay, it's going to look something like that. And when you look at that graph, whether it be by hand or on the calculator, you're looking at like what is happening as you approach 2. Well, I know there's a hole, but what y value is it trying to get to? And if you're looking at your calculator, I mean, you would see that that is a y value of 12. Okay, so you could do it from a graph, just look at the picture. You could do it from an equation, or if you needed to do a table of values. My pen stopped working. There we go. If you needed a table of values, it would be the same thing where you would go to your table, and you would notice that at 2, it would say error, okay? So you would try numbers close to 2, like 1.99 or 2.01. And these values here, once you typed them in using your calculator, I don't have a calculator, so I don't know what it's going to say, but this is going to be really, whatever's here and here, they're going to be really close to 12. Both of them. And in fact, one might be 11.99 and one might be like 12.01, and then you can assume, oh, okay, right in between them is 12, and that's the number that we were trying to get. So that is a rundown of limits using equations or graphs or tables. And just remember, at the end of the day, guys, you are looking for what? The y value. It doesn't have to land on it exactly, okay? But as long as your graph is trying to get to a specific y value, you are good to go. Now, let's get any harder.